Hello and welcome to the KDE Direct Design Engineering episode 11. My name is Patrick Koegler. I'm the owner and lead designer for KDE Direct. And today I'm here to show you our new Propeller Blade Series. So we're very excited about these. And what I'm going to start off with is what does it look like just in the box when you receive it at your location. So what I'm showing you here is one of our dual propeller versions. It's the 18.5 inch, and when you receive this, it'll come into a box for you. When you open up the box, inside you're going to see everything nicely wrapped. We have foam inserts on the end of the box to protect the tips of the blades so there's no damage when you're received to your facility. And inside, I'm going to go ahead and show you this, is your matched balanced pairs of blades. So each set of propellers comes with a set of clockwise and counterclockwise pairs that mount directly to our propeller blade adapters that I'll show you in just a little minute. Very cool. It took us a long time to get to this level of quality. We really wanted to release something that was very unique on the market and very high-end, true carbon fiber laid up propellers. We've been producing these for a while now for some of our larger industrial clients, and now we finally have a chance to bring these to market and show you. So what I'll do is I'll go ahead and open up a set. So they're wrapped nicely together, so go ahead and open them up. And when you take the blades out, you'll see there's also, on some of the series, there's going to be these protective little stickers, so make sure you remove those before flight, or you'll notice a very strange sound when these first start up. So, and here they are. So I'll just grab one blade and so you can really see it. So this particular version is our 18.5 by 6.3 propeller, and as you can see, they're very high quality, very strong, and very lightweight. They're very hard to flex. I mean, these are very high efficiency designs. So the airfoil itself, we actually engineered this custom ourselves to true airfoil design. So they're very efficient, and they're also very quiet in flight. You're gonna notice a remarkable difference in sound, not only from the quality of the construction, but the actual design, especially out towards the tip where all of your vortices and all of the different things happen in the airflow. So you'll see again, there you go, you can kind of get a close-up view. And they are true carbon fiber, so if you section these, you'll see there's no gimmicks being played. So these propellers themselves actually mount to what we call our propeller blade adapters. So in this case, this is a dual format, and the nice part is they're folding. So I'll go into some of the physics of why in flight that's necessary and a very good benefit, but also for just portability. You can imagine you can leave these mounted to your motor, and then when you're done with the flight, you just fold them back for storage. It's very simple, very easy to do, and in this case, this is the dual propeller format. So all of our sizes, we're going anywhere from a 15.5 inch up to a 27.5 inch for the heavy lifters. We're going to offer these in both dual and triple blade format. So here is our triple blade format. So again, when the box is received, instead of pairs of blades, you'll have two sets of triples. And again, they can mount directly to our propeller blade adapter, and you have a triple format. Very cool. And a lot of times clients ask us, well, what's special about a triple blade? What are the advantages there? There's actually quite a few advantages. One of them is if you have a system where you're limited by the size of your rotor span. So in a lot of cases, octos, things like that, they might be limited up to a 15-inch propeller, such as a DJI S1000 or a system like that. Well, at the triple blade format, you can gain upwards of 24% more thrust out of the exact same setup. So for those of you that need more thrust for carrying heavier lift equipment but don't want to spend the money on a brand new frame, or don't want to go larger in a frame where then you start to run into more wind effects and other weather conditions that actually play a role on this larger system, you can switch to a triple and gain that thrust. And the best part about it is for that amount of thrust, for about a 24% gain of thrust, you only lose anywhere from 2% to up to 6% in efficiency. So it's rather marginal in flight. Weather conditions play a larger role in efficiency than that. So it works out very well, and it fills that void of for systems for you where you can really gain a lot more lift. On the heavier lift side, here is our 27.5 inch. Now you can imagine the amount of thrust this can produce. This bolts on to our 72 series motors. So we have a 7208 for very high efficiency flights and a 7215 series for heavy thrust and industrial use. And again, very high quality, very different airfoil on this design. Due to the length of the propellers, there's actually a change in the tip profile, again, to make them quieter and more efficient. So these will directly bolt on, and again, they're portable. That's the best part. You can put these on your large system, and a lot of these 1400 millimeter frames, they're just a bear to transport, especially with those propellers. You're dealing with unbolting and rebolting on propellers and things like that. Well, you just fold them back. You don't have to mess around with any screws at flight or at the field. So, and again, in the triple format, there you can see the amount of lift you're going to get with this thing. This can put out roughly approximately about 20 kilograms of thrust with our 7215 series. So that's per motor. So an incredible amount of thrust and very high efficiency and very smooth. The dynamic balancing of these is just fantastic. That was one of the hardest challenges in manufacturing, was how do we get these perfectly balanced so every time a customer bolts these on, they're not having to do any secondary balancing, any sort of finishing work. They're just ready to go, bolt them on, and off you go. So what I'll show you is how these actually mount to a motor. And in this case, I just have in my hand our 5215 series. This is the 330 kV. And on this particular version, there are 4 mounting holes directly for the adapter. So if I take the adapter, now on our website, there are full instruction manuals on how to assemble these. They're very simple. And the nice part is the actual mounting screws are captured inside when it's fully assembled. So you're never losing screws. You're not dropping them out at the field. You don't have to mess with that and look kind of embarrassing in front of your clients when you drop a couple screws into the grass and you can't find them. So another aspect is there is a lock nut on each blade. So once we set the tension of the blades, you don't have to continually readjust them every flight. Check them about every 10 flights or so just to make sure everything looks good, but you don't have to worry about Loctite and things like that. So the way these will bolt on is they literally will just fit to the top of the motor, and you'll align them until the screws, you'll feel them kind of fit into their place. And then for me, I prefer to use a torque wrench on all my hardware. This one is set to 6 inch-pounds, and you just go through and you can tighten down each screw. And we do have full thread engagement, so a nice strong engagement to the aluminum. And you'll just want to tighten down all 4 screws and you're ready to go. You don't ever have to do this again because they are portable. Now some of our motors only have 2 mounting screws because they're not as heavy lift, so in that case you just use 2 of the 4. It's very simple. And we'll just tighten that down. And there we go. So we're mounted up, and now to go to a flight, we just fold them out. Start your flight, and then when you're done with the flight, you can imagine you just fold these back and out of the way. You don't have to deal with any screws, any hardware, no threads to strip, nothing like that. It's much more durable. Another question people ask is, okay, so what's the tension that I should set these bolts to? So one of the things with these propeller blades you want to do is you don't want them too tight such that they cannot lead lag, but you also don't want them too loose where they just fall under their own weight like that. That's just too loose, and when you go to start up, they'll kind of flop around and clang into each other, and that's no good. So what I recommend is, and we've been doing this for years, is you tighten it to the point where they will not fall under gravity, but they're actually still loose that you can move them by hand. So in that case, what I recommend if you have one is a torque wrench. We recommend 6 inch-pounds and you can just pop it like that, and now you have a nice, perfectly designed and proper tension on the lead lag of your propellers. So you don't have to worry about it, and then just fold them back again and you're done. So real quick into the insight of why we chose folding propellers, not only for the portability but the performance reasons. A lot of physics to this, and I'll go ahead to the dyno bench and show you some of the reasons we chose this, some of the engineering behind here, and I hope you guys really enjoy it, and I'll go ahead and move to the dyno. Okay, so one of the things that we started off with was actually designing fixed propellers. That was the first project we did, and after a few months of development, we found we just could never get to the balancing and the quality that we really were comfortable releasing to the market. And one of the reasons is not only the balancing, but also the dynamics of how a fixed propeller reacts in comparison to a folding propeller, and by the physics of flight. So this is a very common propeller brand out there. We took off the name just to not start any wars, but this is a very common brand out there. So one of the things we did not like about the fixed propeller is not only balancing is much more difficult, but also the physics of flight. So what has happened in the multi-rotor world traditionally is we're forcing airplane style propellers to fly like a helicopter. And in that regard, with an airplane where your airflow is actually coming perpendicular to the rotating blade, it's not such a big deal in that as this rotates around, you have equivalent thrust on both sides of the propeller, and it's not a big deal. If there's any variation, you can dampen that out with a lot of different means. Well, when you switch to helicopter flight, the problem is that air is now parallel to the plane of the rotor, and in a multi-rotor it's the exact same thing. So as this blade rotates around, especially if you're traveling forward or if there's any wind conditions that is against the propeller, this propeller actually, you're going to gain lift on this side of the propeller as it rotates around, and then the retreating blade as it goes away from the direction of air is actually losing lift. And what that does is it creates a natural imbalance of the propeller, and the propeller is going to rock like this at the speed of the RPM of the blade. And there's no way to dampen that out. That's just natural physics of how the airflow and how the propeller works. So one way manufacturers have tried to get rid of that is with adding rubber grommets and stuff like that to the motor mount to try and dampen out that vibration. But the reality is it's the physics of the propeller. Now what a lot of on the smaller side, what we can do is use plastic propellers. So plastic propellers have been used because they can naturally flex and change their pitch during the rotation, and you can help to dampen out a lot of that vibration. The problem with plastic is they're very inefficient. As they rotate, the actual airfoil will flex and move, and that's naturally inefficient. You're going to create a lot of disturbance in the airflow and you lose efficiency. Reason carbon fiber is so desired is that it's much more rigid and very light. So we can gain a lot of efficiency and thrust and still maintain very good flight characteristics. So the other thing we don't like about a fixed prop, so a lot of people will argue, well, if you're flying indoors or there's no airflow disturbance, it's a very calm day, in a multi-rotor you're mostly hovering, so you're not changing any of the aspects and you're not going to be producing what I just told you. Well, that's not necessarily true. In manufacturing, there's always a tolerances. That's just the reality of life. And so what you will always have is an imbalance between pitch on one side and the other. They can never be perfect. So while one side might be, let's say, a 5 rating, the other side might be a 5.1, 5.2. Yeah, it's within tolerances, but naturally when this rotates around, the side with the 5.2 is always going to be producing more lift. And what that naturally does is it's going to cause a rocking like this. You can picture it's going to rock at the RPM of the motor. So not only is that going to produce, again, vibrations that you can't get rid of, but also it puts a lot of load on the motor and the bearings. And so that rocking motion is all being supported by the bearings, and you shorten the lifespan of your motor, and overall your durability goes down, especially on the larger systems. So the big advantage of the folding design is that they can actually lead lag. And so when this rotates around, if there's airflow coming in, one of the propellers will lead or lag depending on the type of airflow, and the other will do the opposite. And that naturally changes the attack angle, it's called, or the amount of effective pitch in the blade. So the blades naturally, by just dynamics of flight, always are compensating for each other, and they balance each other out. And so the balancing of a folding propeller is much, much smoother in flight. It's a remarkable difference in flight, and that's because these blades are allowed to properly lead lag as they need to. Same as helicopters have been done for years in the military, is because if you take a helicopter and you make their blades fixed, it will vibrate itself to death. It cannot fly. It has to have this ability to move in order to balance out those dynamic vibrations. The other thing too is balancing. So balancing is very difficult on a dual propeller design. That's one of the things in manufacturing that took us a long time, was to perfect that. So all of our propellers are matched sets when you receive them. So they're actually put on a dynamic balancing machine, and they're weighted to each other so that you don't have any problems. And so also, as I mentioned with this, if there is any manufacturing tolerance between pitch, and we do our best to make them perfect, these are 5.3s, and let's say one is a 5.35, let's say, these will automatically, again, lead lag to compensate for that variance. So whether or not you're just flying in a stable environment, or you're hovering, or you're flying fast forward, or there's any wind characteristics, not only is your flight controller working to stabilize that, but your blades are naturally reacting to that dynamic motion, and so you cancel out a high variety of the vibrations that naturally would pass through on a fixed propeller design. And so then, of course, the other advantage is just portability. You just fold them up when you're done flying, and you don't have to mess with screws, adapters, anything that will strip out on you, dropping screws into the grass, things like that. That's rather embarrassing when you get out to the field. So what I'll go ahead and do is plug this in. The other question people have for me is, well, it can lead lag, so what about active braking or regenerative braking? One of the technologies our ESCs have that I'm going to explain in much more detail on the following episode is the ability for synchronous rectification. And with that, you have this concept called regenerative braking, where we're actually removing power from the rotor head and putting it back into the batteries. It's excellent for efficiency, and not only that, your flight controller has control of both acceleration and deceleration of the propeller. So you can imagine how much more improvement that is in flight performance. So one of the questions is, well, if we're actively braking, can this fall back and strike each other? Well, the answer is no. The good news is that centrifugal forces, once these spin up, are much higher than any forces trying to move these propellers towards each other. So no concerns about that. Once they spin up, centrifugal forces make them level out to the position that they need to be for perfect flight, and you're going to have no problem. So that's one of the problems also with fixed propellers. A lot of times people are going to what's called like quick release or any of those propeller systems where you can just screw them on. Well, the problem with that is if you go to an active braking system to have better control, they can actually untwist and detach in flight. So highly do not recommend that. In this regard, you're hard mounted to the motor and you have no problems like that. So I'll go ahead and get this plugged in and show you a quick demonstration of how fast and how smooth these propellers are, and then we'll go from there. Okay, so what I wanted to show you here is just how smooth these are, especially in the hovering throttle. So we optimized the airfoil to be very quiet in the 45 to about 60% throttle range, because that's the majority of your multi-rotor flight. So starting these up, as you can see, they're very quiet. I mean, I could talk right over them. And going up into the hovering throttle, right there, you can just hear how quiet they are. I mean, they're just like whisper quiet. So compared to conventional propellers, you're going to notice a very different sound. I could talk right over them. And then, of course, going up to maximum throttle, and I can still talk over them. So one of the things that I'll show you on the next episode is just how fast these can react. And as you can see, there's no problems with acceleration or deceleration on the propeller. As you can imagine, that's a big change, 50% to 100% throttle. I have direct throttle control. You can tell that there's no problem. So, and again, going into, that's 50% throttle, and you can hear how quiet it is. So I hope you guys really enjoy these. They run nice and smooth. As you can tell, I can just put my hand on the bench. There's no vibration. And they'll run nice and smooth for you. I hope you really enjoy these. Turn that off. So that's it for the demonstration. So please feel free, if you have any questions, to email us at sales@kdedirect.com. And I hope you guys really enjoy this new technology. Thanks again.